Mixed numbers, take two. You guys will never know what take one was because I deleted it because I made a simple mistake and I was embarrassed and I didn't want to explain that I made a mistake, so I just deleted it like it never happened. I'm still an excellent math teacher in your minds, hopefully. All right, here we go. Mixed numbers. That's a whole number and a fraction. That's a mixed number right there. When it comes to multiplying these, let's say you have 2 1/4 times 3 1/2. Sorry about my video. There's workers on the roof and it's shaking the projector that's on the ceiling. So if the video is a little shaky, it's the people above me on the roof. All right, how would you multiply that together? Well, my daughter at Sycamore taught me this. She's learning the box method right now for multiplying. So let's do something a little more simple than those two fractions. Let's say it was just 12 times 13. I know that the answer to that is 156, but to do the box method, you'd split up 12 into 10 plus 2, and you would split up 13 into 10 plus 3, and then you would multiply like a times table. 10 times 10 is 100, 10 times 2 is 20, 10 times 3 is 30, 3 times 2 is 6, and if you add all four of those numbers together, you get 156. So that was pretty cool. I never learned that when I was going through school decades ago when I was young. So you could do the same thing with mixed numbers. You could say 2 1/4 is actually 2 plus 1/4, and 3 1/2 is actually 3 plus 1/2. So you could do 2 1/4 on the top and 3 1/2 on the side, or you could do 2 1/4 on the side and 3 1/2 on the top. Doesn't really matter. And then multiply. That's 6. That's 3/4. 2 times 1/2 is 1. 1/2 times 1/4 is 1/8. And then try and add all those together. The 6 and the 1 is easy. That's 7 plus 3/4 plus 1/8. You'd have to turn your 3/4 into 6/8, so you have a common denominator. And that's 7 and 7/8. 7 and 7/8 is the answer to that. 7 and 7/8. All right. That's all well and good. You can do it that way if you want to. The problem is, I don't know how to do box method when it comes to division. Let's say this was 2 1/4 divided by 3 1/2. Now the box method doesn't work for me, and I'm going to have to go old school with you guys and show you the way that I learned how to do this when I was a kid. And that is turn these into just a fraction, get rid of the whole number. And to do that, we do what's called around the world. Around the world. You start at the denominator and you go through the whole number to the numerator. So you start at the denominator and you multiply by the whole number and then you add the numerator. 4, on your way around the world, you hit the 2 times 2 and then plus the numerator. 4 times 2 plus 1. 4 times 2 is 8. 8 plus 1 is 9, and your denominator stays the same. So 2 1/4 is 9/4. 9/4 and 2 1/4 are the exact same thing. They're both 9/4. They're both $2.25. They both represent the same thing. So do around the world with 3 1/2, and you get 2 times 3 plus 1, which is 7/2. Now, if this is a multiplication problem, we already did that. The answer we know is 7 and 7/8 from our box method. Now you can multiply these two fractions together, and when you multiply fractions, you multiply straight across. So 7 times 9 is 63. 4 times 2 is 8. So in take one, I said this was 9/8, and I turned that into a 16, and I couldn't get 7 and 7/8, and I was like, what did I do wrong? And I, for some reason, made that an 8. You never change the denominator when you go around the world. That stays a 4, this stays a 2. All right, how many times does 8 go into 63? 7 times, which is 56, and you have 7 left over, 7 and 7/8. So all these numbers are the same. Two different ways to get it. You can do the box method, or you can turn them into fractions and multiply them together. Now, like I was saying, if you're dividing, I don't know how to do the box method with division. Maybe I should research that. Maybe one of you can tell me. If there's a way to do it, you probably learned it in elementary school. So I'm not going to do the box method if this is a division problem. I'm going to turn them into fractions by doing around the world. So this is going to be 9/4, and this is going to be 7/2, and it's a division problem. Now, when you divide fractions, you actually multiply. You never actually divide with fractions. You multiply, but you have to flip the second fraction first. It's called keep, change, flip. Keep this fraction the same, change that to multiply, flip the second one. Keep, change, flip. So you do 9/4 times 2/7, and that's 18/28, which reduces, because they're both even, into 9/14. So 9/14 would be the answer to that division problem. So maybe there's another way to do this. I'm sure there is, but to me, that's the easiest way. It's not much work. Around the world, flip it and multiply, and you're done. You're there pretty quick. So that's how you divide with mixed numbers. You may run into that today on the do section. The rest of the stuff on the do section is just review, just multiplying, dividing, adding, and subtracting with numbers, decimals, and some are positive, some are negative. So remember, when you're multiplying or dividing, a negative and a negative equal a positive. If you only have one negative, it equals a negative, whether it's first or second. All right, so two negatives make a positive. I will not forget that two negatives make a positive. I will not forget. That's probably not what I should have said, because that means I will forget. I will not forget. So imagine that not wasn't there. That was saying I will not forget. But if you put that not there, I will not forget. That means you will forget. Two negatives make a positive when you're multiplying or dividing. So hopefully you will remember. All right, and then when you're adding or subtracting, it doesn't work that way. If you're doing a -3 minus 4, the answer to that is not a positive number. Two negatives do not make a positive when it's a subtraction problem. This is $3 in debt minus $4 more. Now you're $7 in debt. So this is, you may have understood this. This was the first standard of the year. That may have made sense to you. And then we get to multiply and divide. And all of a sudden, if this was a multiplication problem, say it was -3 times -4, your answer is positive 12. Now two negatives make a positive if you're multiplying. But if you're not multiplying or dividing, then you just go farther in debt. It's just a bigger negative number. So that's the source of many mistakes. And this is my 4th year teaching this, and I just can't figure out the magic bullet on how to get students to understand that this is -7, but if you put them in parentheses, that means now you're multiplying, because when you have two parentheses right next to each other with no plus or minus in between them, that means you're multiplying. So if it's a multiplication problem, your answer is positive, but if it's just a regular old addition or subtraction problem, your answer is negative on that problem. So that's the tricky part with your positives and negatives. If you can get that to sink in, it's going to make your math lives a lot easier for the next 6 to 10 years.